Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And once again, in this hour, we're going to throw the lines open because this hour is your hour. Hello, you're on the air. Any comments or questions?
My name is Ken. I'm calling from Alaska. I want to know if lightning is AC or DC. I'm very curious to know.
Okay,
Love your program. You guys are great.
Okay, thank you. Well, the short answer is lightning is neither. However, it approximates a random amount of DC. That is, it goes in one direction. It doesn't go in two directions. It goes, of course, from the clouds to the earth or from cloud to cloud. And then people wonder, well, is it possible that we can capture this, if it's AC or DC, and use it to solve the energy crisis? Well, believe it or not, we physicists have actually tried to capture a thunderbolt. We've actually gone to areas in the American Midwest where lightning strikes are very common. It's simply not true that lightning ever strikes twice in the same place. And we don't exactly fly kites, but we have electrodes which actually will receive the energy from a lightning bolt. And the question is, can we then harness this for power? Well, the short answer is no. It turns out that the lightning bolts, even though they have millions of volts of power, the energy is basically in one gigantic jolt, and it's very difficult to capture the electricity in that jolt. And so people who have tried to harness the power of electricity have basically failed. Now, the electricity, as I said before, goes in one direction. However, it's not uniform. It's quite random, and it's quite difficult to capture, even though we physicists have actually tried to capture a lightning bolt. And so the short answer is no. And the answer, can we harness the power of electricity? So far, the answer to that is also no. Okay, well, moving right along, let's take the next listener phone call.
Good evening, Dr. Kaku. My name is Dan Hilbert. I'm calling from McMinnville, Oregon. I'm listening to AM 970 in Portland. I'd like to answer the question on why the sky is blue. The sky is blue because the sun, which is really a star, is white, and it reflects off the molecules of oxygen and hydrogen, which only reflect a blue light. If there's some dirt in the atmosphere, then the color would be orange or red. Is that correct? Let me know. Bye.
Well, actually, you're quite close to the actual answer. The answer as to why the sky is blue and why the sunset is red was actually done by Lord Rayleigh. He was the one who figured out that blue light scatters the most and red light scatters the least, and he worked out the mathematics, and sure enough, it is actually true. Now, if you take a look at a rainbow, on one hand, you have blue-green on one side of the rainbow, and on the other side, you have red. And these are exactly the colors that you see in the sky and also at sunset. So what is the difference between sunrise, that is a day sky, and the evening sky? Well, when light comes and hits the earth, it scatters off the molecules in the air, and what you see during the daytime is scattered light. You don't look at the sun directly. Of course, you'd have retinal damage if you did that. You look away from the sun, and by looking away from the sun, you're basically looking at scattered light. That is, light from the sun scatters off a molecule in the air, and then that scattered light goes into your eyeball. What Lord Rayleigh showed over 100 years ago is the fact that blue on one end of the spectrum, blue and green, scatter the most. They're easily scattered, while red hardly scatters at all. Now think of the sunset. When you're looking at the sunset, you're actually looking at sunlight from an angle, and you're looking directly at the sun, not away from the sun because the sunlight is dimmed as it sets. You're looking at the sun directly. Therefore, the amount of air that the light travels is at a maximum. And since red light scatters the least, all the blue light has already scattered away, leaving red. And that's why the sunset is red, and that's why the day sky is blue. So very simply, once again, the day sky is blue because you're looking at scattered light, because you're looking away from the sun. You don't want to damage your eyes by looking directly at the sun. You're looking away from the sun at scattered light, and blue light scatters the most. However, red light scatters the least, and when you look at sunset, you're looking at light that has not scattered because you're looking directly at the sun, where most of the blue light has already scattered away. And so that's why the sunset is red, and that's why the day sky is blue. And it's all a matter of physics and optics. Okay, well, let's take the next listener phone call.
Yes, I wanted to know what the effect that solar cycles had on the current issue of climate change. And I wanted to go ahead and see what we can do to go ahead and augment that, to go ahead and counteract those effects.
Okay, well, you have to separate the question of solar cycles in two parts. One is the question of solar flares, and the solar flares are coming from the sunspots of the sun, and those cycles are 11 years. Every 11 years, believe it or not, the North Pole and the South Pole of the sun flip. And because of the flipping of the North Pole and the South Pole, it creates a burst of energy every 11 years when the sunspot cycle peaks. And some of these solar flare cycles can be disastrous. In 1859, we had the Carrington event, where we had a huge burst of energy during the sunspot cycle that hit the Earth. It was so great that the northern lights, the aurora borealis, could be seen in Cuba, of all places, and you could actually read the newspaper at night by yourself in Cuba. So that's the solar flare cycle. However, there is another cycle that I think you're referring to, talking about global warming, and we'll talk about that after the break. Welcome back to Science Fantastic with Professor Michio Kaku. Once again, it's open mic on Science Fantastic because this hour is your hour. Well, before the break, we had a question about solar cycles. Yes, there are at least two kinds of solar cycles. The first solar cycle is every 11 years when the sunspot cycle peaks, and we have to worry about gigantic solar flares that one day could hit the Earth, like what happened back in 1859 when we had a gigantic solar flare, the biggest ever recorded in history, that hit the Earth. And if it were to hit the Earth again, God forbid, property damage would be absolutely staggering. The American Physical Society, the main organization of physicists in the United States, has estimated that property damage would be $2 trillion in case of a massive solar flare. That's trillion with a T and not a B. Now, there are other solar cycles that are much more gentle, and they take place over centuries. And so we don't think that the current global warming is caused by the increase or decrease in the intensity of the sun. Computer programs have to put this into their calculations, and these are longer-term cycles. When you take a look, for example, at the cycle of the last ice age, you're talking about 10,000 years since we had the last ice age. But when you take a look at what's happening with the Earth today, it's on a scale of 50 to 100 years, which is the reason why, with 95% confidence, most meteorologists who study the question say that there's a component of human activity rather than solar cycle activity, which takes place on a much longer time scale. Okay, well, moving right along, let's take the next listener phone call.
Hi, yeah, I do have a question for the panel this evening. The global warming is obviously a matter of concern, and it's obviously something that is occurring. As a resident of Florida, I'm experiencing it right now with the hottest winter I think we've ever had on record, or should I say late fall. My question, though, is given that third world countries are responsible for a vast majority of greenhouse gas emissions and other pollutants that supposedly contribute to the global warming scenario, how is it that the United States can play a role, in actually reducing the harm that is being caused? Thank you. Bye.
Okay, well, you ask a very interesting question. First of all, even the so-called global warming skeptics believe that the Earth is heating up. You can see that with satellite data, with the recession of the glaciers, with the increase in the summer growing season. You can see that on any number of indicators. The question is, however, of course, how much does human activity have to do with it? Well, when you take a look at greenhouse gases, it is China that is the number one producer of greenhouse gases, then the United States, then India. And so, yes, the United States has to take responsibility for some of the global warming. Now, the third world nations have a differing point of view. Their point of view is that most of the current global warming is due to Europe and the United States over the last 100 years, before the creation of the Chinese and the Indian middle class. And so they say, well, they shouldn't have to bear the brunt of global warming because it's Europe and the United States which started it. Well, yes, that's true. But if you want to rein in global greenhouse gases today, you have to talk to China and India as well as Europe and the United States. We're all in the same boat. And then you ask a question, well, what can we in the United States do to influence China and India? Well, we could do it through negotiations, but of course they are sovereign nations. They have their own agenda. They have their own governments. We can only do it through several ways. For example, through treaties, through conferences, and with trade pacts, so that they begin to rein in some of their global greenhouse gases as well. Second, they say that we are hypocritical because on one hand, the United States in these conferences wants to talk about reining greenhouse gases, yet they continue to spew out large quantities of greenhouse gases. And this is where hypocrisy comes in. What they say in India and China is that America and Europe are hypocritical because they lecture third world countries about greenhouse gases and coal plants and things like that. But they are still one of the largest producers of global warming gases. And so the question is, how much leverage do we have over these countries? They are sovereign countries. However, we can put economic pressure on them because, of course, the world economy is integrated. No nation is an island when you talk about global trade, and so you can put pressure on them in terms of economic pressure. However, the other form of pressure is a moral high ground. Like I said, you don't want to be hypocritical lecturing other people about their production of global warming gases when you too produce your fair share as well. And so I think the point here is that it's a global problem. No one country can solve it, and we're in the same boat. And of course, we have to go to the negotiating table because these are sovereign nations. Once again, in this hour, it's Open Mic on Science Fantastic. Let's take the next listener phone call.
Hi, Doc. I was just wondering about, as far as this climate change goes, who was here? As far as I know, humans were the only ones that ever put out a forest fire or any kind of fire, for that matter. And back before humans, I'm sure there were tremendous fires burning for decades, perhaps. Forest fires caused by lightning strikes, volcanic eruptions causing forest fires, and oil pools being ignited, putting tons of carbon into the atmosphere, and like I said, burning for decades. And I know that we have had glacier melt long before we were here, aka the Great Lakes. So how could this be attributed to humans? Thank you very much. My name is Vince, and I'm in Holiday, Florida, 727-858-4012.
Well, first of all, you're absolutely right in terms of looking at natural phenomena that have affected the weather. The most prominent is volcanic activity. Whenever a giant volcano erupts, the tremendous amount of soot and ash that goes into the atmosphere causes a cooling effect. All this blocks out sunlight, and you can actually measure. You can actually measure this effect, and that's how we know so much about soot and ash in the air, by looking at previous volcanic eruptions like Mount St. Helens and calculating exactly how much the temperature has fallen. Now, forest fires is less of a problem, that is less of a perturbation on the atmosphere. When you take a look at the temperature of the Earth, and you take a look at forest fires, and you take a look at volcanic activity is by far the largest source of change in the atmosphere. So you're absolutely right. In the past, Mother Nature has had tremendous changes. Now, however, that's not the question for today. Today, we don't see gigantic volcanic eruptions, but we have an increase in temperature. These volcanic eruptions cause a decrease in the temperature, not an increase. But what we're seeing today is an increase in the average temperature of the Earth. In fact, 2015 will go down as the hottest year ever recorded in the history of science. And the last decade has already gone down as the hottest decade ever recorded in the history of science. So to answer your questions, yes, in the past, Mother Nature has changed the weather dramatically. In fact, during the dinosaur era, much of the polar ice caps was melted because the Earth was quite hot back then, and the shape of the continents was actually much different because sea levels were much higher because the polar ice caps had largely melted during the time of the dinosaurs. But we're talking about today. And today we see not a decrease in the temperature, we see an increase in the temperature. And we don't see gigantic anomalies like volcanic activities. However, we do see the fact that humans are putting tremendous amounts of carbon dioxide, much more than is released by Mount St. Helens, much more than is released by volcanic activity, and that's the cause of concern today. Okay, well, moving right along, let's take the next listener phone call.
I want to find out about Bangladesh. What happens to Bangladesh if we stop shipping food to them? If global warming continues, Bangladesh drowns. If we stop global warming by stopping coal-powered ships and gas-powered ships, then Bangladesh starves. I would just like to ask that question.
Okay, well, you pose it as if we're between a rock and a hard place. That is, Bangladesh will suffer if we try to rein in global warming gases, but if we don't do that, then the Earth is in trouble. Well, actually, it's not quite that simple. You see, first of all, Bangladesh, because it is right next to the ocean and periodic flooding has been disastrous in the past, will be one of the first nations to feel the brunt of rising sea levels. Already, Bangladesh has experienced some of the largest floods in the last 100 years. And so Bangladesh already is suffering from the rise in sea level. But you see, if we restrict these global gases, it does not mean that they're going to starve to death, because we'll have other ways of shipping food to them. Well, I have to take a short commercial break, but after the break, we're going to continue a discussion of science on Science Fantastic. Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. Before the break, we had a question. We had a question, once again, about global warming. Seems to be a favorite topic for today's discussion. And that is Bangladesh. If you take a look at a map, you see that Bangladesh was once part of Pakistan. And when the British Empire broke up after World War II, India got its independence, but then Pakistan split off, and one part was Bangladesh, the other part was Pakistan under one government. Well, that was obviously unstable, and because of bloodshed, Bangladesh eventually got its own nationhood. Now, unfortunately, Bangladesh is a case study in what happens when sea level rise starts to take place and affect the lives of millions of people. It turns out that, yes, Bangladesh has suffered mammoth, absolutely humongous flooding in the past, and even the Pentagon issued a report once stating that one day perhaps nuclear weapons will be used because national borders may disintegrate precisely because of global warming. Now, if we restrict global warming, does it mean that the people there are going to starve because there are no fossil fuel powered boats? No, there's going to be a mix. We're not talking about going to zero. There will always be some fossil fuels being consumed, always some fossil fuels being consumed. So it doesn't mean that we're going to go down to zero with regards to reining in global gases, okay? Okay, well, let's take another short commercial break, and after the break, we're going to continue with Open Mic on Science Fantastic. Welcome back to Science Fantastic with Professor Michio Kaku. Once again, it's Open Mic on Science Fantastic. Let's take the next listener phone call.
Yes, my name is Paul. It is a fact that global warming is a cycle, and it is caused by the weakening of the magnetism that surrounds the Earth. As it weakens, more of the sun's rays get through, it warms up. As it strengthens, everything cools down again. It's a cycle. Please put this on the air if you're brave enough, of course. I dare you to challenge my theory. This is a proven scientific fact. Thank you.
Okay, well, let's talk about what's proven and what is not proven as scientific fact. First of all, you're absolutely right that the magnetic poles have weakened and strengthened in the past. You can actually see that. Go to Hawaii, dig into the lava flows, and when lava solidifies, the direction of the North Pole is frozen into the lava. And so simply by digging into the lava, you can see that on a scale of hundreds of thousands to millions of years, yes, the poles of the Earth have shifted in the past. Then, if you take a look at the temperature of the planet Earth, you can do that by going to ice cores, by going to Greenland and other places where you have large glaciers and just digging into the glaciers and then extracting the ice. You can then recreate temperatures going back almost 1 million years. Then you compare the two, and there's no correlation. Sorry about that, but the data does not hold up. However, if you take a look at the carbon dioxide content in the atmosphere of the Earth going back 1 million years and superimpose that on the temperature of the Earth, you see that the two go up and down like two roller coasters in tandem. There's an exact match, a match not between the magnetic field of the Earth, but a match between the temperature of the planet Earth and the carbon dioxide content of the atmosphere. So we think, for example, that during the dinosaur era, it was warmer than it is today, And that's why we think that the polar ice caps were smaller during the time of the dinosaurs, but the coastline of the planet Earth was much more dramatically altered than it is today because sea levels were higher. Now, the fact that the magnetic field of the Earth changes with time does have an effect, and that is when the magnetic field of the Earth weakens, it means that the solar wind can blow off more atmosphere into outer space. Look at Mars, for example. Mars is a good example of a planet where we have almost no magnetic field at all. And as a consequence, the solar wind, unimpeded by the magnetic field, has basically blown most of the atmosphere of Mars into outer space. Mars, of course, is smaller and has less of a gravitational field to cling on to its atmosphere. So between having a smaller mass, smaller gravity, and a larger effect of the solar wind, Mars has no atmosphere at all. Now, it turns out that our magnetic field today is weakening. We know that by simply looking at records and by looking at the magnetic strength into the last few centuries, and it means that perhaps in a few more thousand years we will have another flip of the of the magnetic field, and so the North Pole will probably wander. And again, it's not going to happen anytime soon, but on a scale of thousands of years, we do expect another polar shift to take place because the magnetic field of the Earth is weakening even as we speak. And it's been weakening for the past several centuries. And so again, there's no correlation between the magnetic field and the temperature of the planet Earth. The thing that is most correlated with the temperature of the planet Earth is the carbon dioxide content of the atmosphere. And because of global warming today, it means that many scientists believe that it is human activity which is driving the current heating up of the planet Earth. Okay, well, let's take the next listener phone call.
Hi, Doctor. I'm calling. My name is George, and I'm calling from Tampa, Florida, 8:20 a.m. And I'm calling in regards to the alerts we used to have here in Tampa or somewhere here in Florida that we had radon, possibly a radon problem at our home, and around in the area and everything. And I was just wondering, what does that mean, and how would that affect a person's personality or their health issues? Thank you, sir.
Well, you actually ask a question that the government is interested in. It turns out that houses are sometimes built on top of uranium deposits, and it's basically a worry, especially for people in the Midwest. In fact, there was an article in the New York Times recently about it. Radon gas is radioactive. It is a byproduct of the decay of radioactive materials like, for example, uranium, radon, thorium, all have decay products which in turn emit alpha rays. And so definitely, if you suspect there's a problem, have your house tested because radon gas is carcinogenic. It will cause cancer in large quantities. And so definitely, if you think there's a radon problem, have your house tested by the equivalent of the local EPA.
Now, Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. Okay, well, without further ado, let's move on and take the next listener phone call.
Yes, this is Jim from Lake Ozark, Missouri, listening on 1150 AM KRMS. I was wondering where a black hole gets all of its energy from. You just said that we'd have to have the energy of a black hole for time travel, and I was wondering where a black hole got all its energy from.
Well, to make a long story short, a black hole gets its energy from two basic sources. First is gravity. When we talk about a gigantic ball of hydrogen gas, perhaps a light year across, that eventually becomes a star when gravity begins to compress all this hydrogen gas to create a star. And that energy in turn eventually heats up the gas to hundreds of millions of degrees, where fusion takes place and the star begins to ignite, releasing even more energy in the process. So by the time you have a black hole, you have a dead star. All that excess energy has gone to creating a very compact object, very small but very powerful, and so is the gravitational energy, and it's a nuclear force that is then concentrated into a black hole. And then you ask a second part of the question, and that is, well, can you use that to fuel a time machine? And the answer, believe it or not, is yes. If you actually take Einstein's equations very seriously, you realize that if you take a spinning black hole, and the spinning black hole does not collapse to a dot, it collapses to a ring. And if you were to go through the ring, then you would wind up perhaps in another era of space or even time. And this could, in fact, give you a time machine. If you saw the movie Interstellar, you saw not just a science fiction movie with special effects, you saw the work of physicists who actually used Einstein's equations to calculate what it would be like to travel through a black hole. And so the movie is not pure speculation. There's some basis to scientific fact. So why do you need the black hole? You need a black hole to rip a hole in the fabric of space and time. And then you need to stabilize the hole, and that's where you have to have what is called negative energy to stabilize the black hole. So positive energy in the form of a collapsed star is sufficient to rip a hole in the fabric of space, but the hole is unstable. You have to have that negative energy to stabilize it, and then once you have a stable black hole, that's what you saw in the movie Interstellar. And then I should also point out that at the end of the movie, it gets pretty freaky. Matthew McConaughey is seen frozen over the past. And how can you be a frozen individual looking down on a previous era of the history of the planet Earth? Well, that's where string theory comes in, which is what I do for a living. That's my day job. That's what I do for a living. And in string theory, we believe that there are not just ordinary black holes, but higher dimensions beyond the 3 dimensions that we're familiar with. And that's why we had Matthew McConaughey hovering over the past. Basically, he was the present hooked up to the past via what is called a wormhole. Okay, well, moving right along, let's take the next listener phone call.
I'm recalling regarding global warming. It seems to me that a number of years ago I heard that the 4 inner planets have all experienced the same pattern of global warming. Is this true, and could this be an explanation that maybe it is not a man-made cause? Thank you.
Well, actually, you ask a very interesting question that has intrigued astronomers, and that is, if we have the Earth heating up, then what about lessons from Mars and Venus and Mercury? Well, first of all, Venus is the greenhouse planet. So the greenhouse effect is not science fiction. We see the effects of a runaway greenhouse effect. Now, when I was a kid reading science fiction novelists always talked about the oceans of Venus. Venus was supposed to be tropical, a paradise, a place where you could relax on vacation. Wrong. We have sent space probes to Venus. We've actually landed on Venus, and it is a hellhole. It is our evil twin. Size-wise, it's almost exactly the same size as the planet Earth, but its atmosphere is almost pure carbon dioxide. Carbon dioxide that came out of volcanoes. Now, it turns out that volcanoes release carbon dioxide gas, and carbon dioxide gas is a greenhouse gas which captures sunlight. So Venus, instead of being our twin, has become our evil twin. The temperatures on Venus are 900 degrees Fahrenheit. That's as hot as a baker's oven. In fact, it is so hot that elements like tin, metals like tin, actually exist in molten form. So if you were to walk walk on the surface of Venus, it would be rather squishy because your feet would be would come in contact with molten metals. Why is Venus the greenhouse planet? Because its atmosphere is almost pure carbon dioxide, unlike our atmosphere, and the carbon dioxide in turn captures sunlight. And so some people would like to say that perhaps the current warming of the Earth is a natural process, but no. It turns out that the heating of the Earth is not on a scale not on a scale of millennia or millions of years. It's on a scale of 50 to 100 years. And we see on the planet Earth no major geologic changes other than what we humans have done, and that is inject large quantities of carbon dioxide, the greenhouse gas, into the atmosphere. So in other words, the very fact that we do have a greenhouse planet in the solar system gives more credibility to the fact that it is human activity on a scale of 50 to 100 years, not geologic activity on a scale of thousands to millions of years, that is causing the present warming of the planet Earth. And remember that there's really no debate that the Earth is heating up. Even the greenhouse skeptics will admit that the Earth is heating up simply by looking at satellite data of the temperature of the planet Earth, the recession of the glaciers, the increase in the summer months, in the summer weeks. And there's no debate around that. The debate is how much of it is driven by human activity. And by looking at Venus, we see a worst-case scenario. We see an atmosphere that's made out of pure carbon dioxide that captures sunlight, that has made Venus into a hellhole. It is the greenhouse planet. Well, I'm afraid that's it for this segment of Science Fantastic. Let's take a short commercial break, and after the break, we're going to continue with Open Mic on Science Fantastic. Welcome back to Science Fantastic with Professor Michio Kaku. Once again, the lines are open because this hour is your hour. Okay, well, moving right along, let's take the next listener phone call.
Hello there, Doctor. My name is Chris from Washington State, and I've been a painter for 30 years, and I have horrible neurological problems, and I never even occurred to me that it might be because of my profession, but it's just so hard for my body to relax and calm down. I can't sleep at nighttime. I've seen hundreds of doctors, literally, and they say everything comes back, but I've never been tested for any toxic metals, so I'm just wondering if that has something to do with my situation. I can't relax ever, and I don't do any drugs, alcohol, nothing.
Okay, well, the short answer is it's impossible to say without more detailed analysis, but you're absolutely right, though, that certain heavy metals are extremely toxic and in large quantities can cause neurological damage. The most famous is lead poisoning. Lead poisoning is often found in art houses where you have glazes. Lead creates very brilliant colors when it's glazed, and the Romans, at the height of the Roman Empire, used this for their plumbing. In fact, if you are a chemist, you know that the scientific letters for lead is Pb. Why is lead Pb in the periodic chart? Because Pb is short for the Latin of plumbing. And so plumbing was based on lead. Now, some people, I'm not sure if I agree with this, but some people have claimed that maybe the fall of the Roman Empire was accelerated because of lead poisoning, because the plumbing, which the Romans introduced for the first time, because plumbing was all done by lead pipes. And so that is a theory which, of course, can be tested if you go to grave sites, for example, of individuals that lived at the height of the Roman Empire. Then you can analyze the corpses for the presence of lead. Also, mercury is another metal that causes neurological damage. In Japan, there was a famous case of Minamata disease. It was a disease where local villagers came down with horrible neurological problems. And there's even a book a book about the Minamata disease showing pictures of the deformed individuals whose joints and muscles have all curled up in hideous fashion because of large quantities of mercury that were dumped near that village. Now, I remember when I was in high school, we used to play with asbestos, and we used to play with mercury, and we used to say, wow, look at mercury. It's like a liquid metal, right, we would say. Well, those days are gone. Those days are gone because we know that cancer is a byproduct of asbestos, and that metals, especially heavy metals, will concentrate in the neurons of the body and cause neurological damage. Now, again, I don't know your situation because, of course, I haven't seen the numbers, but if I were you, I would definitely get checked out because artists do come in contact with heavy metals, especially those artists involved with certain colors that are ablaze because that's what lead does. And that means that pottery and ceramics made by amateurs have to be tested for lead. It turns out that you have a cup of tea, you pour hot tea into a cup, and within a matter of minutes, if there is lead in the glaze, lead will come out and begin to poison the contents of that cup. And so definitely I would get tested. And again, I'm not saying that you suffer from heavy metal poisoning, but it is a definite possibility, especially it's a hazard for artists. Okay, well, moving right along, let's take the next listener phone call.
7 billion people on the earth, most of them eat animals for protein. What would happen if everybody ate plant protein and did away with the animals, raising animals? And also, it would help greatly if we got all our electrical energy from nuclear power instead of coal, gas. Of course, we can use solar and wind, but that's hardly enough right now. So how much would that save if we use all nuclear power and all plant protein? Wouldn't that be a big help? Thank you.
Well, you make some interesting observations, given the fact that some people have seriously looked at nuclear energy and maybe even plants. We'll talk about that after the break. Once again, we have to take a short commercial break. But after the break, we're going to talk about whether or not switching to an animal diet and switching to nuclear power will save us from problems like global warming into the future. Welcome back to Science Fantastic with Professor Michio Kaku. Once again, in this hour, it's open mic on Science Fantastic. Okay, well, before the break, we had a question, a very interesting question about whether or not we can do something about the environment by switching to nuclear power, maybe solar, wind, and also eating plants rather than animals. Well, let's take them one at a time. First of all, if you have a diet that is rich in plant protein versus animal protein, it's probably healthy. I personally think that there's a lot of truth to what I call the caveman diet. Cavemen, well, they had a diet that was rich in plants, roots, and things that had a lot of roughage, and not so much meat. Meat was actually rare to get in the forest. And we had very little sugar, very little animal fat, but lots of cellulose, fiber, and plant protein. And I think our bodies are fine-tuned like a fine watch. I think our bodies are fine-tuned to live on that kind of diet, and we see the effects of what happens when we have too much sugar and too much animal fat, diabetes and heart disease. However, you can also save on energy a bit. It turns out that plants, of course, are at the bottom of the food chain. Animals like cows eat plants, and then we eat the cows. Each time you go up the food chain, you lose energy, lots of energy, because, of course, you have to feed the cows, and you feed the cows with plants. And so if you ate the plants directly, you could save on a certain amount of energy. Yes, so by switching from a mainly an animal protein diet to a plant protein diet, you can save on energy, but again, it's not enough. Savings you get by switching from plants to animal protein to plant protein is not enough to rein in greenhouse gases. Now, nuclear power is a possibility. Nuclear power does not burn fossil fuels at all. However, it turns out that in order to create enough nuclear power plants to make a dent, to make even a dent on global warming, you'd have to triple, quadruple the number of nuclear power plants, which is simply not going to happen. Nuclear power plants are very expensive. They create large quantities of nuclear waste, and we don't know what to put nuclear waste in the United States. The Yucca Mountains repository has been canceled by President Barack Obama, and so we simply don't know where to put the waste. And, of course, we have the problems of meltdowns. Take a look at what happened to Fukushima, Japan, where we have 4 nuclear meltdowns happen simultaneously after a 9.0 earthquake. And so nuclear power, well, yeah, nuclear power can make a small dent in the creation of carbon dioxide and greenhouse gases, but not much more than that. There's simply too much economic and political pressure in the other direction, preventing a large conversion to nuclear energy. And as you correctly pointed out, solar and wind are also on the agenda, but at the present time, they simply are not competitive economically worldwide with fossil fuel technology. And why is that? Well, basically one word: storage. That is the battery problem. It turns out that we've made tremendous advances in harnessing the power of the sun and wind, but hey, the sun doesn't shine at night, and the winds often don't blow, and so you waste a lot of energy because batteries cannot store the energy efficiently over long periods of time. That's why what Tesla Motors is doing now is quite interesting. Elon Musk is a former physicist, the founder of PayPal, and he says that perhaps solar and wind can be economical if we invest in battery technology. I'll say a few things about that after the commercial break. Are we going to hit the solar era finally once we have batteries that are cheap and efficient? Welcome back to Science Fantastic with Professor Michio Kaku. Once again, the lines are open. Okay, well, moving right along, let's take the next listener phone call.
My question is, in the last, we know that there was an ice age way back when, which means the Earth would have had to have warmed up since then. So why would it have been warming up that entire time and then leveled off? Thank you.
Okay, well, it turns out that yes, indeed, 10,000 years ago we had the end of the last glaciation, and 10,000 years from now, who knows exactly when, we're going to have another ice age. And so we are in what is called an interglacial period. We're at the bottom of the curve. Now, this does not mean that we've had a leveling off of activity. No, it just means that we're in the middle of the cycle. Middle of the cycle. So temperatures are rising, they are peaking now, and will eventually drop again over another 10 to 20,000 year cycle. And these cycles in turn, we think, though we're not positive, are determined by the slight wobbling of the planet Earth. And so we're not leveling off in terms of solar activity at all. It turns out solar activity in terms of the heating of the Earth, it turns out that we are simply in the middle of a glaciation. Welcome back to Science Fantastic with Professor Michio Kaku. Well, once again on Science Fantastic, we profile some of the most amazing developments in science. Okay, well, moving right along, let's take the next listener phone call.
Yes, I was very interested in the Mercury thing because when I was young, I did play with Mercury in school, and it was, how dangerous is it? It's dangerous, evidently, and I would like to know a little bit more about it. Thank you.
Well, yes, you're absolutely right that the more we learn about heavy metals, the more we learn that some of the things that we used to think were harmless are actually not harmless at all. First of all, we have a nervous system which is very sensitive to certain kinds of chemicals. These chemicals concentrate in the nerves and impede the firing of nerves, and therefore can cause all sorts of neurological damage. As we mentioned before, the Romans used to use a lot of lead. Artists today even use lead because of the brilliant colors created by the lead glazes. But if you put a hot tea in a cup made with lead, the lead will actually seep out within a matter of minutes. And so, yes, when we were kids, perhaps we played with mercury. We used to call it quicksilver because it was a liquid metal, a metal whose melting point was near room temperature. And we played with it, but now we realize the fumes that came out of mercury are actually quite dangerous. Also, the greatest scientist of all time was probably Isaac Newton, who may have suffered from mercury poisoning. It turns out that there was a period in the life of Isaac Newton where apparently he went crazy. Apparently he was just acting very irrationally, and he was doing experiments in alchemy, what is now called chemistry, and he was exposed to large quantities of mercury and mercury fumes. And these mercury fumes will, in fact, then go into the lungs, into the blood, and concentrate in the nervous system, where it can cause neurological damage. And so you're absolutely right. If you think that you have been contaminated by heavy metals, then by all means get tested. A very simple test of your blood will determine whether or not there's large quantities of heavy metals, and get tested, because things that we used to play with as kids, like mercury, like asbestos, like lead, the more we know about these things, the more we realize that some chemicals can cause cancer, like asbestos, or can cause neurological damage, like lead or mercury. Okay, well, let's take the next listener phone call.
Yes, Professor Kaku. I was wondering about in the idea of Mars travel, seeing how what we have done with probes and whatnot to the planet, why not try and send just one probe to land on Mars and send something back to Earth, at least perhaps just to Earth's atmosphere? I'd be very interested to know what you think about that. Thank you.
Okay, well, you raise a very interesting point because, of course, the NASA recently announced a major shift in its orientation, and that is in 20 years, approximately 20 years, we do want to send a manned mission to the red planet. So now we actually have a rough timetable by which we will explore Mars. And you raise the interesting point about what about sending a probe, and a probe not just to collect data that is sent back to Earth, but perhaps a mission of retrieval. That is, the probe would scoop up some Mars rock and then blast off back to the planet Earth, and so we would have Mars rock in the laboratory. That, of course, is one of the goals of this missions to Mars, and that is retrieval of Mars rock. Now, believe it or not, we actually do believe that we have found Mars rock on the planet Earth. So there is some precedent here. When you look at meteorites that have landed on the planet Earth, cut them open and look at the air content that's been trapped inside the meteor, tiny, tiny pockets of air. you find the atmospheric distribution of gases is identical to that of Mars. So the chance that this came from Mars is almost 100%, because like a fingerprint, we have almost an identical chemical composition of the Martian atmosphere compared to the Earth's compared to the atmosphere found in the meteorite. Now, this has led some people to believe that perhaps life might have started first on Mars, and then a meteorite may have landed, crashed into Mars, and blown Mars rock into space, where it drifted for millions of years and then landed on the Earth, where we picked it up. In which case, if life started on Mars first, then some people speculate that perhaps we are the Martians. Perhaps life started on Mars first, DNA gets off the ground, then makes the interplanetary journey to the planet Earth, lands on the Earth, and then contaminates the Earth with DNA. Well, of course, all of this is speculation, but hopefully in the coming years, NASA will have rock retrieval, by which we'll have real Mars rock that didn't have to make this interplanetary journey from Mars to Earth, and with that, determine whether or not perhaps life once started on Mars. Well, that's it for Science Fantastic. Once again, join us every week. Join us every week for a discussion of science at its best. The mysteries of science decoded on National Radio.
Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And once again, this hour is your hour because we're going to throw the lines open. Okay, well, without further ado, let's take the listener phone call.
My name is Steve. I listen to you on WGOW. 11:50 a.m. in Chattanooga, Tennessee. I'm interested in how things happen. Do we live in a deterministic universe? Or do we live in a random universe? Or do we live in a universe that's still a mystery to us and we don't know how things happen? I'm not interested in why things happen, but how they happen. Thank you.
Well, you ask a question that goes right to the heart of science. Isaac Newton would have said centuries ago that we live in a deterministic world. That is, everything is determined ahead of time by his 3 laws of motion. Therefore, there's no uncertainty, there's no doubt. The universe is deterministic. And he said the universe is like a clock. God wound up the clock at the beginning of time, and the clock has been pretty much unfolding ever since, right on schedule. This also has philosophical and religious points of view, because some religions believe in predestination, and that is, we're all determined ahead of time whether we're going to go to heaven or hell. According to predestination, there is a book in heaven with your name on it. Your name in this book. It gives you your birth date, it gives you your death date, and it tells you whether you're going to go to heaven or hell. That is predestination. Well, that question about determinism split the Catholic Church in half, because the Protestant Reformation, the revolt of the Protestants who protested in part, thought that it was evil to believe in predestination if you were rich and you could buy your way into heaven. It turns out that back then, hundreds of years ago, there was corruption in the Catholic Church on the question of determinism, that even if you were destined to go to hell, you could buy your way into heaven by making generous donations to the Catholic Church. Well, Martin Luther didn't like that, and he posted his, 95 Theses on the church and set off the Reformation, the revolution, the Protestant Revolution. So the question of determinism goes right to the heart of religion. Who determines if you go to heaven or hell? Is it written ahead of time, or can you change your fate by doing good works? Now, what does the quantum theory say about this? The quantum theory, which has been proven billions of times. In fact, all of our modern day society is based on quantum electronics. The quantum theory says, well, no, there is no determinism at all, that there is no book in heaven with your name on it, giving you your birth date, death date, and whether you're going to go to heaven or hell. There is uncertainty in the world. Uncertainty means that you cannot predict with absolute accuracy whether or not the universe will unfold this way or the universe will unfold that way. There is uncertainty. In fact, there's a new TV series called Man in the High Castle about a fictitious world where the Nazis and the Japanese Imperial Army won World War II. The advertisement shows the Statue of Liberty with a swastika on it. And if you read the book, if you actually read carefully the story of the Man in High Castle, written by Philip K. Dick, you'll realize that it's actually based on the quantum principle. It turns out that according to the book, in the 1930s, somebody tried to assassinate Roosevelt, fired a bullet, and it was a quantum decision whether the bullet will fire correctly and kill Roosevelt or not. In one universe, the bullet did not fire. Roosevelt was spared. We won World War II. That's the universe that we live in. But in this other universe, because of the uncertainty in the chemicals of the gun did not fire correctly. There was a misfire, and as a consequence, I'm sorry, I got it backwards. Sorry about that. In one universe, there was a misfiring of the gun, and that's the world where we live in. However, in another universe, the gun did fire correctly. The bullet did fire, hit Roosevelt, killed Roosevelt. There was chaos in America. The vice president was very pacifist, and as a consequence, we lost World War II. And so the whole TV series, in fact, the novel Man in a High Castle, is based on that one quantum event, and that is, will the gun fire or not fire? Well, what's the answer to that? The answer to that is at the atomic scale, you cannot determine it. You don't know for certain whether an electron will go to the left or go to the right or go someplace in between. And one day, computers may be based on that principle. One day, computers may have to compute on individual atoms. And so this academic question of determinism and predestination, this academic question could actually determine the nature of the world economy when computers are based on quantum atoms. Okay, well, let's leave the quantum world for now and go back to the world we live in. Let's take the next listener phone call.
Good evening, Dr. Kaku. My name is Dan. I'm listening on 970 AM, Portland, Oregon. Now, I know you have touched on this subject, but I don't know if it has ever been properly addressed by the scientific community. I contend that in any solar system, there can be only one planet at any given time in that solar system that harbors animal life forms. Additionally, neither can there be a two-sun solar system or a binary star system containing a planet that harbors life as we know it on Earth. I call this the Hilbert hypothesis. According to Isaac Newton's laws of gravitational attraction, planets need to be separated far enough apart in order to maintain stability. Only one planet in any solar system at any given time can host human life forms, and a binary star system, due to its widely fluctuating orbits of planets and suns, can never sustain human life forms. What are your thoughts on this, Doctor? Thank you. Well, believe it or not, your question is a question that's debated by astronomers as we begin to catalog over 1,000 solar systems in deep space. And the question you ask is the same question that astronomers are asking. In other words, can you have a solar system with two suns? Or can you have a solar system with perhaps two planets in the Goldilocks zone that may support life? Well, we can actually answer some of your questions now because we have so many. In fact, we have an encyclopedia of planets circling other stars in outer space. First of all, you're wrong on one question. The question is, can you have a solar system with two suns? We used to think that was unstable,
But hey, we find them now. We actually see double star systems, that is, two stars chasing each other like a dog chasing its tail, with planets going around both at a faraway distance. Now, of course, if the planets are too close to the double star system, they'll tumble into the stars, but it is a stable solar system if the planets are far away from the double stars. So you have two stars like a dumbbell that chase each other, and planets that go from a very large distance around the double star system. Now, the other thing you said is, can you have a solar system with two planets with life on them? Well, take a look at our solar system. We have the Earth in the so-called Goldilocks zone, not too close, not too far from the sun. If we're too close, water will boil. The oceans would boil. If we're too far from the sun, the oceans would freeze. In each situation, there's no life on those planets. However, look at Mars. Mars is just on the edge of the Goldilocks zone. We once think that, well, perhaps life did get off the ground on Mars 3 billion years ago. You can't rule it out. And so here we have a situation where we have two planets, Earth and Mars, that conceivably could harbor life forms. And so once again, we are constantly surprised by the diversity of these solar systems. If you saw, for example, Star Wars, in the Star Wars, the first episode, there was a double star system. And many people wrote letters, angry letters, saying, bah, humbug. Star Wars is based on fake science because you can't have that. Well, lo and behold, we do have them. And so we're constantly being surprised by the diversity of solar systems. And you're right that in general, we think that most solar systems perhaps only have one planet in the Goldilocks zone, but you can't rule it out anymore. We have all these oddball planets being cataloged. If you can imagine it, perhaps it exists out there in the solar system because they are in the universe, because there are so many planets we are now cataloging. Welcome back to Science Fantastic with Professor Michio Kaku. It's open mic on Science Fantastic because this hour is your hour. Okay, well, moving right along, let's take the next listener phone call.
Hello, Dr. Kaku. I'm calling in regards to, well, let me first say that I'm calling from WPSN area, 104.4 in northeastern Pennsylvania. And my question is about gravity. Particularly about the speed of gravity. We all know that the speed of light is the ultimate in regards to speed, but does this include also the speed of gravity? If the sun disappeared instantaneously, would gravity also disappear instantly or at the speed of light? I'd appreciate your answer. Thank you very much.
Okay, well, your answer actually is not resolvable at the present time, but I'll give you the consensus of almost every physicist who studied the question. If the sun were to disappear right now, we know that it would take 8 minutes for the light from the disappearing sun to reach the Earth. We wouldn't know it for 8 minutes. Now, Einstein says nothing can go faster than light, even gravity cannot go faster than light, meaning that we wouldn't feel the gravitational shock wave for 8 minutes. The Earth would not be thrown out of its orbit and flung into deep space for 8 minutes. And then the question is, how do I know that? No one has ever done this experiment. Gravity is very weak unless you go to the galactic or the stellar scale. And so for the most part, you never feel the effects of gravity that can be measured easily in the laboratory. So it's quite difficult to do experiments on gravity, and nobody has measured the speed of gravity because gravity would change so quickly. However, every scientist believes in relativity theory because it works every time, and so we think, but we cannot prove that it would take 8 minutes for the disturbance of the vanishing sun to reach the planet Earth. Now, one day we may be able to do this experiment with quasars in outer space, with exploding stars, exploding black holes and things like this. But at the present time, our technology is not sophisticated enough to answer the question, how fast does gravity travel? But I'd be willing to put money. I'd be willing to put money on the table and say that if there's a disturbance in the universe someplace, we wouldn't know until the gravity wave reaches us at the speed of light. Okay, well, let's take the next listener phone call.
This is James calling from Montgomery, Alabama. 93.1 FM is what I'm listening to. I wanted to know, what is love? Is love, and can love go beyond death and life, as we love someone who has died, and years after they're dead, and we feel that they're still is somewhere in existence? Also, I had one more question. What is the energy that leaves the body as the body dies? Is it considered the soul, and where does it go? Exactly does the love come from, or the energy that leaves the body? Where is it centered, and where does it come from as it leaves the body?
Well, you ask a very profound question, and let me be blunt. If I knew the answer, I would yell it out from the top of a roof, announcing that I've understood the secret of love and the secret of the soul and life itself. Quite frankly, I don't know, because, you see, science only goes so far. Believe it or not, there are limits to what is knowable. The limit to what is knowable in science is the question of reproducibility, falsifiability, and the ability to do an experiment and get testable numbers out. Theories have to be testable. So the question is about love, about energy, about death. Is there something about death that can be measured? Well, it depends on how you define death. If you were to define death to be the point at which the brain dies, you are brain dead, and then you would ask the question, what does that mean? It means that there's no more electrical activity in the brain to speak of. The conscious parts of the brains are not firing correctly. However, if you mean soul, then the question is, well, how do you measure soul? How do you define it and how you measure it? Scientists once thought that perhaps the soul could be measured by weighing the body of a person just before death and then weighing the body of a person just after death. Well, these experiments can be done, and you find basically no difference at all. And so, in other words, scientists are not saying there's a soul or no soul. No, we're not saying that. We're just saying that it's not measurable, that people have tried, come up with negative results. It doesn't mean there is. It doesn't mean there isn't. It just means that it's out of the province that we usually call science, the body of testable, reproducible, and falsifiable statements. Welcome back to Science Fantastic with Professor Michio Kaku. Once again, the lines are open. You're not going to get a busy signal. Okay, well, let's move right along and take the next listener phone call.
Hi, I was just listening to your show today, and you were talking about bulldogs and people snoring and why only bulldogs snore. But obviously, you've never heard a Newfoundland snore or had a bigger dog snore with a snout. So therefore, I feel that you are not accurate in what you present on your air and on your show.
Okay, well, you actually may have a point. I got the information from a science book, and it said basically the following, that over millions of years, animals that had a snout sometimes lose that snout because of natural selection or breeding, like, for example, the bulldog. And that compresses the membranes of the mouth, and therefore animals which don't snore with a large snout then begin to snore because all the membranes begin to touch each other when air begins to move. And why is that important for us? Because that's the reason why we snore. If you take a look at the bones of our ancestors had snouts which were much more pronounced than ours. In fact, if you take a look at our closest genetic neighbor is the chimpanzee, which has a very prominent snout. And so most dogs, wolves, for example, because that's where dogs come from, do not snore. However, some people pointed out, well, my dog snores. Well, the point is that the more compression you get of the snout, like, for example, one person called in and says, I have a pit bull. He snores. The point is the more compression you have of the snout, as in a human, the more wind flutters as it goes across our windpipe, and the more you snore as a consequence. Are there exceptions to the rule? Well, apparently there are. But in the main, on average, if we take, for example, 100 dogs, you would find that the dogs that snore the most would be the dogs that have the shortest snout, because these are the dogs that have had their membranes compressed together. So you may want to do a science experiment, Put your dog to sleep one day and just stay up a while and see whether your dog snores or not. But that's the general rule, that we humans, we also snore, because over millions of years, our snout began to get smaller and smaller and compress into our face, pushing membranes close together. Our mouth has changed quite dramatically over millions of years. For example, that's why you have to remove your impacted teeth. Many teenagers have to have their 4 teeth in the back molars, removed, because our jaw has been getting smaller. Not only has our snout been getting smaller, but also our jaw has been getting smaller over millions of years. And basically, there's no room. There's no room to fit all the teeth. And that's why some, not necessarily everybody, but many teenagers have their molars removed, because there's simply not enough room over millions of years that our snout and our jaw has been getting smaller and smaller. Okay, well, moving right along, let's take the next listener phone call.
Hello, Professor. My name is Deanson. I've kind of followed space since I was a long time. But my question is, with these ion rockets, you say they can last a long, long time, but what will be the source of the ions, and won't we ever need to refuel with them? Thank you.
Okay, well, your question has to deal with a larger question. Many people ask a simple question: what will replace the chemical rockets? We all know that chemical rockets only go so far into outer space. If we're going to go to the stars, if we're going to go to other solar systems, we're going to have to need a new rocket system. The next rocket engine beyond the chemical rocket is the ion engine. The ion engine shoots a beam of ions, which is not dramatic. It doesn't make your heart flutter. In fact, it's barely visible, and the thrust can be measured in ounces and pounds rather than millions of pounds for a chemical rocket. The advantage of an ion engine is, however, that you can fire it for years at a time. A chemical booster rocket may send hearts aflutter as it blasts off Cape Canaveral, but the booster phase only lasts for about 5 minutes or so, and then it's all over. However, an ion engine can be turned on for years at a time. And the other advantage is the amount of fuel is not so much, because you're talking about a very high efficiency for the ion engine, so you don't have to take on enormous quantities of fuel. However, you do obviously have to have fuel, because the fuel is ionized and then sent out the other end. Now, some people have speculated that maybe the fuel source, instead of bringing it with you for an ion engine, maybe you can use the hydrogen in deep space. And that would be a novel device that could basically last forever. It would scoop hydrogen from the forward direction like a ramjet, burn it, and then shoot it out the other end. That device is called the ramjet engine. And a ramjet engine may, in fact, give you unlimited amounts of fuel, because you're scooping up hydrogen in the forward direction. Unfortunately, they don't exist yet. We don't even have fusion yet. But it's something to dream about, thinking about rockets beyond chemical rockets. Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. Okay, well, let's move right along, and let's take the next listener phone call.
Over the past million years, hasn't there been polar ice caps
that had gone all the way down into mid-U.S. and then back up again without people having been present? Thank you.
Well, the answer is yes. Ice ages come and go, but they come and go very slowly on a scale of tens of thousands to even millions of years. The last ice age, for example, ended 20,000 years ago. Other ice ages have taken place before humans were alive. Now, some people use this to argue, therefore, that perhaps global warming is not caused by human activity. But you see, in the last few decades, we've had a spike in the temperatures on the planet Earth, which is not part of the normal cycles, which go over thousands to millions of years. Like I said, 10,000 years ago, we had an ice age. We were under half a mile of ice in North America. 10,000 years from now, we'll probably be under another ton of ice when the next ice age starts, and we are between ice ages. But the recent activity is causing concern, and that is just within the last few decades, we've had a tremendous spike in temperatures. In fact, 2015 will probably go down as the hottest year ever recorded in the history of science. The decade, our decade is perhaps the hottest decade ever recorded in the history of science. And have you noticed that things are changing dramatically, not over thousands of years, but over years? Talk to any farmer, and every farmer will tell you the summer is about a week longer than normal. Talk to any geologist, and they'll say that every glacier on the planet Earth is receding, not expanding, on a scale of decades, not millennia. Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. Okay, well, let's take the next listener phone call.
Hi, this is Laura from Tampa Bay. There's a billionaire, I don't know his name, but he came up with an idea to pump the cold water at the bottom of the ocean up to the top to weaken hurricanes. And he's waiting for a patent. The inventor of the Internet didn't even wait for a patent, although he won a contest for $1 million, which is how you get things done, by the way. We should start a pool and give it to whoever cures cancer. Thank you. Bye.
Okay, well, I don't know who this billionaire is, but I think I can reconstruct the idea. First of all, where does the energy of a hurricane comes from? It comes from warm water. That's where the energy comes from. So if you have cold water from the bottom of the ocean and were to circulate it upwards, you could reduce the temperature of water and therefore cut off the supply of energy for a hurricane. Sounds simple, right? Well, in practice, I tell you, man, in practice, it would be incredibly difficult. First of all, how big is a hurricane? A hurricane can be hundreds of miles across, feeding on the energy of millions and millions of gallons of warm water. There is simply no engine big enough that can circulate cold water on that scale to cool down hundreds of miles of warm water. Second of all, these hurricanes move. These hurricanes start off as some kind of breeze off the coast of Africa. They sail across the Atlantic Ocean, gradually building up energy. They hit the Gulf of Mexico, where they get a wallop of energy from the warm water there. And then they plow into, let's say, the United States. So you see, this air mass travels very quickly. So even if you were to cool down the water in one area, just a few hours later, the hurricane has already moved ahead. And so that doesn't work. I tell you, man, we scientists have beat our brains out thinking about all sorts of ways that we might be able to use science to prevent hurricanes, and we all come up negative because the energy of a hurricane is massive. They're huge objects. They travel at very fast velocity, so that most of the ideas that have been tried simply don't work at all. Another idea that was tried was, since hurricanes start as a sea breeze off the coast of Africa, why not interfere with that process? For example, seed the clouds, make it rain, try to change the weather off the coast of Africa so that they don't get started to begin with. Well, weather control and weather modification was tried, most famously by the CIA during the Vietnam War. During the Vietnam War, there was something called the Tet Offensive. And why not induce monsoon rains to wash out the communists so that they could not create another Tet Offensive? Well, that failed. The CIA was abysmally incapable of controlling the weather in order to wash out a Tet Offensive by inducing a new monsoon season. I tell you, people have tried for centuries. Kings and queens facing battles have tried to modify the weather. Modern scientists have tried to modify the weather by seeding clouds, and that hasn't worked at all. So I'm not saying it's impossible. I'm just saying that it's really, really hard, and it's supremely expensive to find some way to modify a hurricane. Another possibility that is sometimes raised is, why not detonate a hydrogen bomb? A hydrogen bomb has a ferocious amount of energy. Why not drop a hydrogen bomb in a hurricane and tear the hurricane apart? Well, it sounds simple until you realize that the energy of a hurricane is much greater than a hydrogen bomb. A hydrogen bomb, if you take a look at photographs of the mushroom cloud, it's not stretching out over hundreds or almost 1,000 miles. But that's the radius of what can be attained by a hurricane. And so hurricanes are massive objects, and a hurricane, I think, would simply eat up a mushroom cloud of a hydrogen bomb. So back to the drawing board. Well, we're beginning to run out of time, so let me paraphrase one of our listeners who called in and left a long message, and that is, he wanted to know the temperature of outer space. And he wanted to know whether there was a difference between hot and cold. Is it symmetrical? Can we have infinite coldness and infinite hotness? Is it symmetrical? And what about the temperature of outer space? Well, to be very frank, the temperature of outer space is, about 3 degrees above absolute zero. In fact, that is the temperature of the Big Bang today. The Big Bang spewed out energy that pervaded the entire universe, but it cooled down. And if you do a calculation, 13.7 billion years after the Big Bang, the temperature, the average temperature of the fireball is 3 degrees above absolute zero. And bingo, that is the temperature of outer space. And so believe it or not, the temperature of outer space today is the temperature from creation itself. And is it symmetrical? No. You can have infinite heat, but you cannot have infinite coldness. Absolute zero is the bottom. You can't go below absolute zero, because at that point, all molecular motion stops. Okay, well, unfortunately, we have run out of time.
Have a question you need answered? Call 800-449-8255 is the number to call during the week to get your question to Professor Kaku. That's 800-449-8255.